Are you familiar with generics and templates? Have you ever seen a piece of code and wondered what the angle brackets could mean? Have you ever wondered if you use a single function for different types? Let's dive into the concepts of generics and see what they mean and what they are used for.
Good day everyone, I'm Oguchi Beze from Beam Variant Technologies. I'm a programmer and web developer, and in this tutorial I want to talk about generics. Generics is a concept that helps us write functions using dynamic data types. I'm going to use an example to illustrate exactly what I mean. Let's look at these two classes that we have right here. We have the book class and the car class. Let's assume I want to create a new class that can be able to embody a function that can now be able to create a list of a book or a list of a car. So how do I go ahead to implement this? Let's go ahead and create class. I'll scroll right down so I can be able to see those classes very nicely. So here, say book list, and I'm going to go ahead and implement a default constructor and also an add method. So we need to do that. Let's say public returns void. I'll call this method add. I'll put in my brackets in the right places and this should work. So I'm going to go ahead and call in a book as a parameter that should be specified here, and then this is going to be book. Now let's not write any code writing, and if I wanted to go ahead and also create a list of cars, so I'm going to say class car list, and I'll put in a default constructor as we have that, and also place in an add method. So I'll say public void to show that it returns nothing, and I'm going to place in the add function also right here. So it's not going to be doing anything. So let's see how this works. And I'm going to have to add the parameter inside of my function. This should be car. This should be car corresponding. Now let's go ahead and try creating an instance of this list and see how far or how much we can add into the car list or the book list. So for me to create the instance of the car list, I'll say var, say car list. You see this is equal to new car list. So that should work. And then if I call the car list and I hit on dot, we'll see that we have access to the add method. So I just click on the add method, and then of course if you check as a parameter needed here, I'm going to need to add a new car. So I'm just going to say new car in that way, and this works fine. Or better still, I'm going to create a new class, a new car, and then go ahead and add it as a method. So this is supposed to be var car is equal to right there, new car, and then now pass car as a parameter here, and this function just works fine. You can also go ahead and create an instance of a book list. So I'm just going to say var book list is equal to book list. I should have my new keyword. Okay. Then if I go ahead and call book list dot, of course we also see the add method being presented here, and I can go ahead and pick a parameter. Now of course you see this also takes a book that is needed, so I'll just say new book. So this works. I'm still going to go ahead and do a little bit of refactoring. And my refactoring, I'll just go ahead. I think maybe I didn't specify parameter that this is going to need a book. Actually, I did. So I'm going to go ahead and create a var. Let's say book is equal to new. I can have that already copied. So right here, I can specify that this is going to be a book. So this code works very fine. But then here's the problem. This code is a bit redundant. That means for every type of data that I'm going to be represented inside of my code, I'm going to have to create a corresponding list to display that. And this is the problem that generics have come to solve. It helps us to be able to create one class list and then be able to bring in the type alongside the class or the function. Let's go ahead and see how this works. Alright, let's create a single list that can accommodate all data types. So I'm just going to go ahead and get rid of this and get rid of the car list and the book list, class. So I'll just get rid of these classes. Now let us talk about the generic list in this case. So I'll say class, I'll call this generic, okay, to spell that properly, list. So now after calling the name of the class, so the next thing we have is some angle brackets, and the angle brackets I'm going to place in T. Now this T is a variable, is a placeholder for a data type, but we're going to have to specify this at runtime. So let's go ahead and see what happens. So here I'm going to place in my public, my default constructor, and also go ahead and place in that add method I had before. So I'll say public void, I'll say add. So that should be it. Now let's go ahead and see what this is capable of holding. Of course, I have to specify the variable that I want to be held inside here. So I'm just going to say this is going to hold T, which is a data type that has not been instantiated as we have it, but it's going to have to be instantiated just now. So now I can go ahead and say that this is var generic list. Let's say this is equal to new generic list. Then I'll go ahead and specify an angle bracket. Now in this case, I can say as a parameter the type I want to pass in here is a book. So this is very much recognized. So if I call the generic list dot add, now if you check right here, the parameter I can be able to add here is a book T. So I can just create an instance of book, a new book. I say new book, and this works fine. Of course, remember from, I'm just going to do a little factoring, just do a little bit of some separation of code. So I can say var, it's a book is equal to that's new book, and then I'll come in here and pass in book. I can also use the same generic list, but then I wanted to create also space from the add method for cars. So I'm going to say var, I'll say generic list 2. So I have to just alter the name just a bit. And I'll say generic list, and this time the angle bracket, I'm going to specify that what I want here is a car. So placing brackets that way. Now if I call generic list 2, I'll click on dot add. Now you see that this time the variable that I need to pass in here is going to have to be a car. Of course, I'll go ahead and place a new car as usual, and this works right fine. So I'm just going to go ahead and do the factoring I've been doing here as usual. So var car is equal to that guy, and I pass in car as a variable right here. So this works right fine. This is exactly the problem that generics helps us to solve. Now we have just one function, and now we can be able to add in different types. Now let us go ahead and also see that we can be able to add some of the primitive types that we have inside of C#. So I can call generic lists value types to actually be precise. So I can say 3, and I'll call in here new, and then I'll pass in calling generic list class. So generic, and then inside of my angle brackets I can place in integer as my T. Remember T from the data type variable. So I can say var I'll just call generic list 3, and I'll say dot, I'll place in the add method. Now if we place in here, you see that the variable that is needed or required here is an integer in this case. So I can just place in 10, and this works. So of course this helps us to achieve, this is a dynamic type. We have just a single add function and can be able to take dynamic variables. So I think polymorphism going on here. We have a single add function, but then depending on what type specified at the instantiation of the generic class, we can actually be able to use or add different data types into our add method. In addition to what we already have, our generics can actually also go ahead and take in multiple variables or multiple values for our data type. So I can go in here and also specify that this can also have u and v. Of course, this is a convention, so you don't need to worry about it so much. So I'm just going to go ahead and create a new function called public. I want this to return nothing. I'll call this map, and I'm going to map in 3 values. So don't be scared. Hope it works. So I'm going to say t should be mapped to u and v. So that's no implementation, so I hope this just works. So I can go ahead and create a var and generic list as I was doing in the first case. Generic list, it should be equal to new generic list. In this time I'm going to have to pass in 3 parameters. I can decide that the book should map to car and the end should map to an integer, and this works very nicely. Of course, my 3 parameters are specified, so I can go ahead and add things. So I can call generic list dot, I'm going to call the map method this time. It's a map, and in this case I'm going to pass in the 3 types I already have. So I'm going to pass in a new book, I'll pass in a new car, a new car, and finally I'm going to have to also pass in an integer. Let's say 10, presuming. So this works right fine. The function is actually going to run because I've actually passed in the values that I required. Now, although we have learned how to, I can actually be able to create generics, you might actually not need to be creating any one as you're working, because generally in C# there are a lot of built-in generics that we can actually be able to have. So if we go ahead and check in system dot collections dot generics, I'm placing a dot, I'm going to see a list of all the generics that are possible inside C#. So we actually not need to be creating a generic class as we go, because actually you can see we have lists, the queue, the sorted list, the sorted set, the stack. Of course, we have the key value pair, to also help us illustrate the map that we have. We have the iSet, the iRead-only collection, iList, and so many others. So this set of generics can actually be able to help us to solve a lot of problems that we already thought about right here. And of course, you can actually go in and explore some of them. So I'm not going to do that now. I'm just going to go ahead and keep on explaining generics as we know it. So the next thing we need to talk about in generics now is the constraints that we can add to generics. So of course, as we just checked in, we can add in any kind of data to generics. Like in our case, we put in a book, car, ink, and whatever can go in here. Value type, the reference type. So whatever type can go in here. But of course, we can actually go ahead and place in restrictions to make sure that whatever generic list that we have can actually be able not to take in all kinds of data. So let's see exactly how this works. So assuming I added a constraint into this, I'll say where, and I want to add a constraint to t to be specific. So I'll say where t is a class. Now this is making an explicit constraint addition to t, saying that t should be a class and t cannot be any kind of a value type or whatever. So let us see how we can actually be able to use this. So if I go ahead and say var, I'll call this generic list. I say this is equal to new generic list. Generally, everything we have in C# is a class anyway. So let's just go ahead and see the range of values that we can add here. Now, since t can only be a class, so I can say book, I can say car, of course, let's leave int. This still works. But now let's try to change our book with, let's say, a value type, something that's not a class. So int, as you can see, int is a struct in C#, and of course if we check right here, we see that there are curly underline under here trying to indicate that this is not a class. So explicitly we cannot be able to place in int in this place. So that is adding a constraint, trying to make sure that we cannot just go in and placing any kind of value inside of t. So t must have to be a class. So of course this can be car, as in case I have that, or book, or any of the other default C# classes that we have. So we're going to look at other constraints too. Yeah. So in addition to class, you can actually go ahead and specify that this should be a struct, for instance, and we say this is a struct, where t is a struct. You can see this also throws up this red colon underline, trying to indicate that this is not a struct. So of course we can place in an int now in this case, because now it specifies that t should be a struct. Now this is also part of the constraint that we have, and we are specifying that here. So we have 4 constraints, and I'm going to just place them as comments. Yes, one is where t, for instance, because we have tuv, so you can specify for all 3, be a class, as in the case we just saw, or where t, also in our example, is a struct. We've seen an example of that. Also, you can specify where t is a class with a default constructor, and also we can also check where t is let's say an instance of an interface, and let's say an interface like iComparable. Let's just spell that right. So of course I can just go ahead and just show an example of that. So let's say this is an iComparable right there. So of course int is an iComparable. Go ahead and specify book. Book is not a member of an iComparable. So I can go ahead and make book an iComparable by implementing this iComparable interface inside of book. Of course, that would be very easy to do, but I'm not just going to do that now. I'm just trying to show you that since book does not implement iComparable, then it doesn't fit, or is not compatible or compatible with this constraint that we just set in here. So this is how we can actually be able to go ahead and set in constraints for our generic list. Now the last thing we're going to talk about generics is that generics cannot only appear or cannot only be seen inside of a class. You can actually also have just the generic functions. I'm just going to get rid of this one and go in and create a function. This time it's going to be a function that wants nothing, but then I'm just going to call it generic fun, whatever that stands for. And then I'm just going to go ahead and specify. Let's change this function into a generic function. I'm going to put in my angle brackets and specify t right there. And I say in this function, pass in t. So let's just go ahead and say console.writeLine of whatever we put in it. So I'm just going to say cw, so code snippet, and then I just want to console.writeLine t. So if you call this function generic fun, and then placing the angle brackets, we can now go ahead and specify what data type t should be. So of course we didn't specify any. Go ahead and placing t here inside my brackets, you can see that this function will be able to accept an integer. So that's not saying that just now. So yes, this can accept an integer, so I can place in 10 as a value here, and this works just fine. I can also go ahead and change this to a book, and of course I can call in new book, and this also still works fine. So I have it. Of course I can change this to a string, and this can now be able to take in a string. So let me see hello as a string. So this works just fine. I can go ahead and run this function or run this code, so let's just see exactly what we get. Okay, we can see this prints out hello to the console. That's fine, because just like we talked about the int, if I see int here and I pass, and of course this value becomes obsolete and actually not useful, generates an error. I pass this, then we see that this also goes ahead to give us 10. So this is fine. Now, one other concept that can actually look like this, or can actually try to solve the problems that generics can solve, is all called function overloading. So function overloading, which one do we use, or which one do we implement between function overloading and generics at every given time? Of course, this could be a little bit of a debate, but I think that there is a clear favorable use case as long as both cases are concerned. So for me, I only say use a function overloading when you need to define multiple functions with multiple arguments. Let's say, for instance, you have a function that can take one argument, 2 arguments, 3 arguments, and 4 arguments, and you need all of these functions. You can actually go ahead and use function overloading and create 4 of these functions while specifying different parameters for different function. But then I favor generics, using generics when you have to define multiple functions with different argument types, data types. So now in this case, just like we're looking at, if you want the data type to change, not necessarily do you want to use multiple functions. So if you want the data type to change, as maybe for a function, let's say for a sort or a check marks, you want to check a sort function. For instance, a sort, you want to be able to sort integers, you want to also be able to sort to doubles and floats and things of that nature. I would also sort strings. So you can go ahead and use the generics to be able to do that, and I think it's going to work well and give you the desired results. So thank you and God bless. I'll see you in the next one. Thank you.